Hi there! Around the globe, many scientists are working to better understand the greenhouse phenomenon. I by myself has been working with climate change for many years, and one of the things I always missed is a very clear, simple and at-hand explanation of what on earth is this greenhouse effect. Those scientists, they have computer models, fancy graphics, nice animations. But as our budget is somehow smaller, this is our greenhouse model. The very nature of the greenhouse effect involves our atmosphere, the very air that we breathe. The sunlight reaches the atmosphere, that just like a greenhouse. Let the light from the sun goes in, this light reaches the surface of Earth, increasing the temperature, the surface starts to emit heat from the surface of Earth to outer space. Just like in a greenhouse, this heat, when it reaches the glass, it's trapped inside the greenhouse. What increases the temperature inside the greenhouse? What does it mean? Means light from the sun comes, reaches the atmosphere, goes through, reach the surface, increase the temperature of Earth's surface, who emits the heat. When this heat tries to go to outer space, the very atmosphere blocks and traps it inside the atmosphere. And this is really interesting and good for us, because it helps to regulate and stabilize the temperature on Earth. What happens is that when mankind increase the emissions of the greenhouse gases like the carbon dioxide and change the chemical composition of our atmosphere, it actually becomes more efficient in its greenhouse effect. What does it mean? It means that the same amount of sunlight get in, reach the surface of Earth, irradiates the heat, and when the heat tries to escape to outer space, a smaller amount manages to go through, and more heat is trapped inside the greenhouse, inside our atmosphere. And what happens? The temperature on Earth rises. Assembling the thermometers, we are going to use the wires in order to fix the thermometers inside the jars. Thermometer A without atmosphere. Thermometer B with normal air atmosphere. And thermometer C, our greenhouse gas atmosphere. In this case, we are going to use a candle that when we light, it will consume the oxygen and produce the CO2 or carbon dioxide, one of the greenhouse gases. It's important that we make sure that the thermometer C, which will track down the atmosphere reach of greenhouse gases, is well assembled. So we will light the candle, make sure it burns stably, then go with the jar slowly, very nice, very easily. The main idea is that when the flame is, because there is no more oxygen and the candle already produced the maximum amount of carbon dioxide, we have the jar closed. No hurry. Candle extinguish. Yep. Close firmly the jar. We have the lamps. In order to simulate the heat from the sun, we will switch on the lamp and see how it goes. 3, 2, 1. Ignition. 16:25. Thermometer A, no atmosphere. 21. Thermometer B, normal air atmosphere. 24. Thermometer C, greenhouse gas atmosphere. 24. 4:30. Thermometer A, 23.5. Thermometer B, 27. Thermometer C, 27.5. 16:25. Thermometer A, 25. Thermometer B 29.5. Thermometer C 30. A quarter to 5. A 25. B 32. C 33. 10 to 5. A 25. B 33. C 34. 10 to 5. A 25. B 33. C 34. So we have the first line in blue, thermometer A with no atmosphere. The second line in black, the thermometer B with normal air atmosphere. And at last, but not at least, the red line, our greenhouse gas atmosphere, thermometer C. One of the things we can notice is that as soon as we switch on the lamp, there is an initial huge increase on the temperature. And around 4:30, there is an inflection point where this temperature keeps on increasing, but with a lower speed. Already in this first part of the experiment, we can notice a significant difference between the thermometer A and thermometers B and C, what starts to indicate to us the importance of the atmosphere in the Earth's temperature regulation. 20 to 18 hours. A 26.5, B 36, C 36.5. 10 to 18 hours. A 27, B 36.5, C 37. 18 hours. A 27, B 36.5, C 37. In both of the thermometers with the atmosphere, we have a stable condition. That's the point when we choose to switch off the lamps and to see how the temperature drops. 6:15, A 22, B 29, C 29. 18:25, A 21, B 25.5, C 26. 19:45, A 20, B 23, C 24. 19 hours, A 20, B 22, C 23. 19:25, A 20, B 22, C 22. 7:30 afternoon, A 20, B 22, C 22. At the moment that we switch off the lamp, all thermometers have a significant temperature drop. The thermometer without the atmosphere very quickly at 7 o'clock already had a stable temperature of 20 degrees. The other two thermometers, they fall down to temperature very quickly, almost together. But then what you can see is that the thermometer with normal atmosphere loses temperature faster than the thermometer with the greenhouse gas. And at 7:30, both of them have the very same temperature stable, which is the point that we choose to end this experiment. Now that we came to the end of our experiment and the end of our film, we hope that you have a better understanding of the very nature of the greenhouse phenomenon and how it actually supports life on Earth, making the temperature on Earth more stable. The question that remains is, as humankind keep on emitting more and more of the greenhouse gases, will this have an impact on the Earth's temperature? But this is another story. See you next time.
Necesita medicina y un poquito de amor que le cure la penita que tiene. La tierra tiene fiebre, tiembla, llora, se duele del dolor más doloroso. Y es que piensa que ya no la quieren. La tierra tiene fiebre, tiembla, llora, se duele del dolor más doloroso. Y es que piensa que ya no la quieren. Y es que no hay respeto por el aire limpio, y es que no hay respeto por los pajarillos, y es que no hay respeto por la tierra que pisamos, y es que no hay respeto ni por los hermanos.